Okay, so for the next couple of videos, we're going to look at the center of mass for integration and solids. Okay, so we've looked at in the previous section, we looked at the center of mass of laminas. Okay, and how we can use some of their shapes and their properties to find out the center of mass. Okay, now what we're going to look at today is we're using integration method. Okay, for a lamina still. Okay, but it's for the reason of shapes that don't have like these lines of symmetry or don't have nice formulas to go with them, and we need different methods of how to be able to solve it. Okay, so we have some formulas, okay, which are above. The main two are these two red ones down here. Okay, we're going to use some integration to be able to find my center of masses. Now these aren't given in the form booklet, okay, so they are ones that we need to remember. Okay, but majority of these are mainly used for our solids, which we'll do in the next video. Okay, but first of all, we're going to look at laminas. Okay, so we'll jump into this first example. We've got a uniform lamina. Okay, it cuts shear plastic, so that its edge is between x is 0 and x is 2 pi, and then it goes y is 0, and it gives me this equation here to use. Okay, so that's the equation I'm going to use when I use my integration during this. Okay, now again, the main thing of you spotting of when to use integration and when to use the other method is the fact the other method was all used of like semicircles, quarter circles, rectangles, triangles, all those kind of things. Okay, whereas this one, that's a function, okay, which doesn't have these nice properties to go with it. So straight away I've got a function. It's going to have to be some de-integrated methods. Okay, so find the center of mass and then it's suspended. So let's do the first bit first. Let's find this center of mass. Okay, so to do so, I need to find these key points up here. So if you notice, both of the two equations up here have this on the denominator. Okay, so I'm going to do that bit first. So I'm going to integrate between a and b. Now, a and b are my x limits, so between 0 and 2 pi in this case from the question. So from here. And I'm going to do that of my y function, so 2 plus sine x. But let me do it with y first. Let me write it out. So I'm going to write my formula. This one I'm doing AB y dx. There you go. That's what I'm trying to do. So let me put my functions in. So I've got between 0 and 2 pi, and then 2 plus sine x. Okay, now normally we'd follow all our normal integration rules at this point, plug it in, work it out again. It comes out as 4 pi. Okay, we still need to do all our workings and stuff like that. I'm just going to speed it up for this kind of example, okay, so we know how to integrate stuff like this. Okay, now I need the other two bits. So for the x one, I need to do xy. So you take my y function and times everything by x, and then for the other one, I need to do a half y squared. Okay, so let's do the xy one first. So I need to do xy. So same limits between 0 and 2 pi, and I'm going to have x times by my y function. And again, just plug in my calculator. Okay, I'm going to get 4 pi squared minus 2 pi. Okay, and then the final one we need to do is integrate between a and b of a half y squared. And then that's going to be the integral between 0 and 2 pi of, and then I'm going to have a half, and then 2 plus sine x all squared dx. Okay, and that's going to come out as 9 pi over 2. Okay, so there's all my like components. So I need to go away and find those three bits first, and then I can just plug them into the formula. Okay, so my x bar is going to be xy over y. So xy is the 4 pi squared minus 2 pi all over, and then all over y, which is 4 pi. Okay, it's going to come out as, if I can simplify it, I can take a pi off everything. It's going to leave me with pi minus a half. Okay, so there's my y. So that's my x. Now let's do my y. Similar kind of thinking, I'm going to have my 9 pi over 2 all over 4 pi, which is going to come out as 9 over 8. Okay, so therefore, center of mass, and let's write as a coordinate. Okay, so it's got pi minus a half and 9 over 8. Okay, that's my center of mass. I'm going to plot it on my thing roughly. Okay, so pi minus a half, let's go for roughly about here-ish. Okay, just an example. So now what happens is it's freely suspended from 0, 2. So 0, 2 is going to be this point up here. Okay, so it's freely suspended from there. Find the angle that's the edge joining 0, 0. Makes with the vertical. Okay, so if I draw my line through these, that's gonna, if I can draw a better straight line than that. Oh, no, okay, I can't, that's fine. So find the angle, the edge joining 0, 0 and 2 pi make with the vertical. Okay, so I gotta think about what, there's my vertical. Okay, I'm going to be looking for, if I carried on this purple line, I'm going to be looking for this angle here. Okay, now quite awkward one because I don't really know where it's going to cross on this x-axis. Okay, so it's going to be quite awkward for me to work out. So instead, I'm going to use a little bit of angle rules, and that should be the same as this angle up here. Okay, so if I'm thinking of it like that, I want this angle up here. I need its height and its length. Well, I know its length because it's straight from 0, so its length is pi minus a half. The issue is its height is the issue here, this height that I want. I know from 0 up to here is 2, and I know the centre of mass, it has a height of 9 over 8. So this little height here is going to be 2 minus 9 over 8. Okay, so we're going to go straight into it. We're going to go, okay, that means alpha must be 10 to the minus 1 of 2 minus 9 over 8 all over pi minus a half. Okay, again, I've got pi's, make sure we're in the correct things at that point, okay, 18.3. Okay, it shouldn't actually matter because if I change into radians, it wouldn't matter too much, okay. Radians or degrees depend on the question, okay. It hasn't really told me which one. I should probably put it into radians, okay, but we can convert that quite quickly anyway if we need to, okay. So key bits, formulas in the red box are going to be really, really important for us, and then if we need an angle, draw a little diagram, think about what lengths you want. If you need to add something on or take it away. Okay. Apart from that, we're going to look at solids in the next video. Okay, so I'll see you in the next video.